in the libc library. And what do we do here? We're just passing a normal closure. And what we get for those two items, we get 2 pointers. So we know that they're going to be int32s at those memory addresses, get int32 for each, do a normal Ruby comparison, and then return the appropriate result. And libc handles making all this stuff work from Ruby, that you can actually do a C call with a callback, just passing a normal Ruby closure to it. That's pretty cool. And this one is also extremely exciting to see run, so I'll run this one. Hopefully, is it sorted right? Yes, it's sorted right. Wow, it works. Okay, so, but I mean, you get the point. This is really cool that any C library out there, you can easily just do a little FFI binding logic and call it from Ruby code. And I think it's definitely, if it's not the only language that can do this on the JVM, it's probably one of the nicest APIs for doing this. Definitely the cleanest looking. Okay. So on from FFI, a couple more challenges that we faced. One was to have we needed a full set of I/O APIs for Ruby. The challenges with Ruby's I/O APIs is that they're essentially libc I/O, so file star and file descriptor and all that stuff. It's all smashed into a single structure. When you've got an I/O, you can do both buffered and unbuffered I/O, sockets and files and pipes and everything. All it's exactly the same. It's all I/O objects. And we had to make it all look right. We had to have the non-blocking characteristics work correctly. Had to have that work across all of the different I/O channel types on the JVM. So initially it was simple java.io wrappers. And that worked pretty well. But when we started to need to do select calls and typical NIO asynchronous stuff, we needed to do a complete re-implementation of it. So the impossible task here was implementing all of the libc I/O semantics just using NIO. And it needed to basically look like the libc calls, with file descriptor dupes and reopens and other things like that, but still be based on just Java APIs. And so this was mine. I did this one. It was horrible. I recommend never ever looking at glibc IO code if you can help it, because that is basically what I had to do to understand some of these calls and how they're supposed to work. But it functions. It works pretty well, and I hope you never have to do it. So if you want to help pull this library out, this is another one that could probably benefit a lot of people. Kind of a general abstraction that's like file star and like file descriptor with a bunch of the APIs that go with it, buffered IO and so on. And as far as I know, there's no other library that does that on the JVM right now. So performance. Performance is the never-ending task. When we first started, this is probably even conservative. I think we were more like 100 times slower in the C implementation when we first got Rails working in 2006. And obviously, even 10 times slower wouldn't cut it. People would not use it. Ruby was already not a particularly fast language. And if we were 10 times slower than that, the benefits just wouldn't outweigh that performance cost. So the string and regular expression work, all that stuff really helped. But we needed to do a lot more work on the runtime. So the impossible task was making Ruby fast, a language that had never been made to run fast before. We had to do it on top of the JVM, which, as everybody knows, is slow, right? So it was kind of an impossible task in two ways. We had to make Ruby fast when nobody had ever done it, and we had to prove to people that the JVM could actually run Ruby faster. So we did a lot of little tricks. We did our own method handle generation. Essentially, it's our reflection-like layer, but it's not using reflection at all. Rather than doing method.invoke calls all the time, we've actually generated about 1,000 little tiny classes that represent each of our core methods, so that we can just call it straight through and not have all the reflection plumbing in the way. Only way to get it to run really well and get the performance up. Having different call paths through the system for one argument and two argument. If you've ever used Java Reflection and do method.invoke, you're always boxing stuff into an array. And then that has to go as an array through the system and then be unboxed on the other side. And that's an extra overhead that you have to pay. So our handles have separate paths for 0 up to, I think, 10 arguments now. Then, of course, working on a bytecode compiler, which I wrote basically all of the compiler over last summer sometime. And it all works pretty good. There's also new JVM work that I'll come back to in a minute. But we can do a quick demonstration of this. Performance demonstrations are always so thrilling. So here, this will be, I've got a little fractal benchmark on
bench fractal. Okay, so we'll run this, we'll run it one time. I think that's the right command line for it. Okay, so it generates a w.r.t set. Okay, so that is our performance. Yeah, it's a little bigger so it formats correctly. You can actually see the w.r.t float by. Okay, so now I'll run it with Ruby 1.9, which is currently the fastest C implementation. Ruby 1.9 runs this in about 2.5. So already we're doing a lot better on performance than the fastest C implementation of Ruby. But the interesting thing when you run it on JRuby is that this is only the first run. If we actually run this for a few more times and let the JVM really start optimizing it, so the first time will be about the same. Flip by pretty fast. Well, let's see, the second time, 2.1, we get down to 1.4, 1.2. Yeah, so ending up at about 1.26. And if we look back at the Ruby 1.9 result, 2.5. So, you know, we're getting comfortably faster than Ruby 1.9 at this point. And we've also got additional things, like if I really wanted to run fast, I'll pass the fast flag to JRuby, and then it'll run even faster. It's like the turbo switch, you know, the turbo one, right? We'll run it fast. Okay, so, well, 1.3.2, so it didn't do a whole lot in this particular benchmark. But we got more plans, we've got more stuff that we're doing, working on optimizing compiler stuff over the summer, working on the JVM, the Java 7 stuff. Let's go back to the slides and see. Okay, so after performance, okay, so here's another good one for us. Another challenge for us is actually presenting normal Java types. We wanted to be able to have people implement Ruby libraries, Ruby code, still call it nicely from Java. And this is still kind of an ongoing thing. The impossible task we have is that we need to produce a normal looking Java type that is actually Ruby code underneath. And this is impossible for a lot of different reasons. Ruby doesn't actually have type declarations. What you do when you open up a class, and say class foo, you're creating a new class object and then running a bunch of code against it. It's not actually a class declaration at that point. So for us to have any sort of static declaration or static representation of a class, there really isn't anything until runtime. Once we've got a normal class at runtime, then we can go and look at it. Because all classes are built at runtime. So initially we thought, oh, maybe we can figure out some subset of Ruby or some static inspection we can do. We'll just read through the file and assume that this is what the class looks like and produce a Java class. And it just didn't feel right. The way that we actually have ended up writing our Ruby to Java compiler now is that it loads the class up. It loads up whatever libraries you want it to load, and then inspects the runtime definition of that class. And that's what it produces in the Java type. So if we look at some examples here, there's this Ruby to Java project, which is it's still kind of experimental, but it's coming along. Ruby to Java. Okay, so the idea here is that we wanted to be able to write Ruby code, throw a couple Java signatures on it so that you to represent whatever the Java code is supposed to look like, and then have a normal Java class come out the other side. So if we look at a simple example, here is a little Ruby class, Ruby main, with a class method defined, main, that just iterates over the arguments and prints them all out. Normal Ruby code, completely simple Ruby code, it's just normal stuff that run on regular Ruby. What we do to actually bind this as a Java method is down here, we say we want to stuff a static signature for a static method into the main method. We want it to take Java lang string array and then produce a normal Java void. And that's all that's necessary for our compiler to then turn this into a normal looking Java class. I'll go out to the command line here. Ruby to Java. And this is also available as a gem, so if you wanted to run it, gem install Ruby to Java will get you there. I already have it installed, so I have a Ruby to Java command. And the arguments to this command are what class I want it to inspect at runtime, which in this case is just Ruby main. And then what Ruby libraries I want that class to depend on. In this case, it will again just be Ruby examples Ruby main.rb. Okay? So I'll run this. It'll load up the Ruby main library, look at the Ruby main class, and what we get out of the
what we get out of this is a Ruby main class file,